Hello, algebra students. Mr. Lawrence here, and I thought I'd make a quick video on graphing exponentials. I want to make sure that you're getting what you need out of this and you're understanding the finer points because it's quite simple, but if I blow through it too quickly, I'm not convinced that you're going to get it. All right, now, I normally would not do this, okay, but I'm pretending like we haven't learned this at all. And so I'm going to put a whole bunch of inputs in and find out what's happening with the graph. Okay? Now some of you already know what's going to happen, but some of you have been absent and are a little bit lost. So if I put 3 in, 3 to the third power is 27. 27 minus 2 is 25. If I put 2 in, I get 9 minus 2 is 7. I can plot that one. Let's see, right about there, right? 9, 8, 7. Yeah, that's right. Okay. If I put 1 in, I'm going to get 1 out. If I put 0 in, I'm going to get negative 1. Then if I put negative 1 in, I'm going to get 1/3. 2 minus 1/3 would be negative 1 and 2/3. Right, so negative 1 and 2/3. Okay. If I put negative 2 in for x, I'm going to get 1/9, so I'm going to get negative 1 and 8/9. Right? So we're getting closer and closer to negative 2. Now, many of you know that there's going to be this asymptote, right? The asymptote, and the asymptote is going to be like a barrier. It's not actually part of the graph, but all the values are approaching it. They're going to hug it as x gets smaller and smaller and smaller. I apologize, it's very difficult to draw a curve with this pen. Do it much better on paper. Okay, so this is the asymptote. The asymptote. And its equation, well, it's a horizontal line, it's negative 2. Its equation is y equals negative 2. Okay, and no, it's not a coincidence that there was a negative 2 right here in the equation. That tells us the asymptote. All right, and we get this nice curve. It's going to continue to climb and climb and climb. And here it's going to get smaller and smaller and smaller, closer and closer and closer to negative 2 from above, but it will never touch. Okay? Now, when I have this blue one here, it's going to have the same asymptote, y equals negative 2, because it's right there. Y equals negative 2 is the asymptote. But as many of you already realize, this negative on the base is going to change values. It's going to change things up a bit. So let's see how it's going to affect things. All right, so I'm going to have negative 3 to the power of x minus 2. And I'm going to put the same values in to see what happens. Okay, if I put 3 in, I'm going to get negative 127, so I'm going to get negative 2 and 127. That's pretty strange because I don't know if you notice this, I am below the asymptote. Yeah, I'm already below the asymptote. Okay. I didn't make a mistake there, right? 327. Oh, I did make a mistake. Silly me. Silly me. Sorry. Yeah, I thought that didn't look right. Sorry about that. Let me check my math again here. All right, if I put 3 in, I'm going to get 27. That'll be negative 27. I'm going to get negative 29. Okay, that's better. All right, when I put 2 in, I'm going to get negative 9. And then minus 2 will be negative 11. So 2 is going to be at negative 11. So maybe here. And then 1 is going to be negative 3, negative 5. Okay. 0 is going to get me 1, negative 3. Yeah, that's right. 0 equals negative 1 because it's the negative of 3 to the 0 power. Just like, remember, this was the negative of 5 squared. Remember that? It's negative 25. Okay, this is the negative of 3 to the 0 power. All right, now when I put 3 to the negative first, I'm going to get 1/3. It'll be negative, so it'll be negative 2 and 1/3. So negative 1 is at 2 1/3, negative 2 1/3. And look at this, all my points are below this line, the asymptote. All right, when I put negative 2 in there, I'm going to get 1/9. I'm going to get negative 2 and 1/9. So I'm getting closer and closer to negative 2, just like I was, except I'm approaching it from the bottom. Okay, same asymptote. So here's what happens. Here's what happens. And again, I apologize. It's difficult to draw those curves with this pen. I'm using my airliner. All right, so what do you see from that? Well, what you see is, uh-oh, I lost my mouse. Connection lost. Danger, Will Robinson. Come back. Oh, we're reconnected. Yay. Oh, look, a sock report. Good to know. Okay, so what did we discover here? Well, my mouse is disappearing. I'm getting frustrated. Ooh, it just caught back up. This is crazy business. When I have the equation y equals 4 to the power of x plus 5, first of all, I know the asymptote is going to be y equals 5. Secondly, I know that all the points are going to be above the asymptote. How do I know this? Because the 4 is positive. It's a positive 4. Okay. And I know that it's going to, didn't intend to do that in highlighter, but I guess it's okay. It's going to tend to go like that towards the asymptote because the x is a positive. Okay? But if I do y equals negative 4 to the power of x plus 5, it's going to do the same thing, except it's going to be a reflection across the asymptote. And so it would do something like that. Okay? So making the base negative causes the graph to reflect across the asymptote. Okay? Now, on your own, perhaps using Desmos, I want you to experiment with what will happen if I do this. Many of you already know, and that's awesome. If you can just tell me, that's great. And of course, I want to know about this. Okay? On Friday's test, you're going to have some type of error analysis where it's going to be expecting you to interpret another student's work and correct them if there is a mistake. And it will be involving these graphs. So you need to be practicing that. If you want to come get help on it, please come get help on it. But if you just blow it off, I promise you, you will miss those points. And the error analysis points tend to be, 4 points on the test. So that can be significant, sometimes 15, 20% of your grade. All right, Mr. Lawrence signing off. Have a good day, everybody.